So following on from the previous video, we've seen that if you get a graph plotter and plot y equals 10 to the power of x, it will give you this red line here. And then if you get a graph plotter and plot log of x, it will give you this blue line here. And as it turns out, the log of x is the inverse of this function here, because well, it's a reflection along the y equals x diagonal line here. Okay, so when you have any function, if we know that from our section on functions, if you create an inverse function, then you're so you would start out with this, and then you would then create this function here, and you would start out with this function here. You don't know this thing here, but then you want to create an inverse function of this thing here, whatever that may be. Well, from our section on functions, if you want to create an inverse function of a function, then you reflect it along the y equals x line, and there's a reason why that is. You've got to scroll back, you've got to track down that video and try and understand why. Because when you have a machine here, and if you put something into here, let's say if you put x into here, you get y. If you create a machine that if you put y into here, it will spit out the x here. It's really the x and y's, they get switched around, giving you the impression that it's a reflection along the y equals line. So whenever you have a function, if you want to create an inverse of whatever function that you're trying to create the inverse of, it will always turn out to be a reflection along the y equals x line here. Well, anyway, we don't know this here. We would start out with this thing here. We just want to create an inverse of this thing here. So to create that inverse, let's reflect it along the y equals x line here, the diagonal line here. It will then give us this thing here. So now we've got, in a way, a machine here. That is the inverse of our original function here. Okay, so well, anyway, now let's extend this to base e. So now we've got we now have a function y equals e to the base of e to the power of x here. We don't well if you get a graph plotter and plot natural log of x, so there should be a button on your calculator looking like ln. So that's your natural log here. That's this bit here. So if you punch in log natural log of x here, then it will give you this this blue line here. Now this blue line here is really the inverse of this red line here. It is a reflection along the diagonal y equals x line here. So this is an inverse of this, and in a way this is an inverse of this blue line here. Well, when we first start out, it would be y equals e to the power of x. We don't know this here, but then the thing is, we want to create an inverse function, because if we have an inverse function, we can later on come up with theorems, with new theories of doing, with new ways of doing things that, well, we can formulate new things if we know the inverse of this. So we would start out with this and try to create an inverse of this thing here. Well, the way you create the inverse is by reflecting it along the diagonal y equals x line here. So when you reflect this line, it will give you this blue line here. So we're gonna give this line here a special name. We're gonna call it the natural log of x here. Okay, so this natural log of x here is the inverse of this thing here. Okay, so now we can let's try and visualize this whole scenario here in terms of our two machines. So at the moment we've got our normal machine here. This here is our red line here. Hang on. E of x is our red line here. Okay, e of x is our red line here. The blue line, the natural log of x, is the inverse function. So you can think of this in terms of our two machines here. This is our normal f of x. This here is our inverse function here. Okay, so looking at this here, if you put a number into this machine here, let's say 0 here, 0, then that would be e to the power of 0. So it would spit out the number 1. Okay, and then the thing is, if you now put this number 1 into your inverse function, it will then spit out what you originally put in there, which was this 0 here. Okay, so the point here is looking at this here. If you put 0 into our original function, that's our starting here. If you put 0 into this thing here, it will spit out the number 1, meaning that if you put 0 into here, then this whole thing here will be the number 1. So that means if you put 0 into here, then the whole thing here will be the number 1. Now put the number 1 into your inverse function. So now put this number 1 into your inverse function, which is this one here, and then it will spit out what you originally put in, which was x, which was 1. Okay, so the point here is that if you put 1 into here, so if you put, sorry, I'm being silly. Hang on, let's start again. If you put 0 into here, if you put 0 into this thing here, then this whole thing here will be 1. Because if you put 0 into this machine here, the whole thing here will be 1. That's this one here. Now if you put if you put the number 1 into here, if you put the number 1 into your inverse function, if you put the number 1 into your inverse function, that means if you put the number 1 into your inverse function here, it will spit out the number 0. So this thing here is 0 here. So originally we put 0 into here, and then blah blah blah, it will spit out the number 0 over here. That means, looking at this here, looking at our original function, if you put the original function into the inverse function, that means if you put the original function into the inverse function, that means this is your original function. Put it into the inverse function, which is this log thing here, then it will give you it will spit out what you originally put in there, which was x. Okay, so looking at this here, well, this here will work for any function. Whenever you have a function f of x, and then you've got an inverse function, this bit here will always be true. Will always be true. Now, looking at it in our case of e to the power of x here, if you're looking at this, the original function, put the original function into the inverse function. So put the original function into the inverse function. That will give you this here, and then it will spit out what you originally put in there, which was x here. So using this, we can then get to this here. So natural log, well, whenever you see this here, these two will cancel each other out, leaving you x here. Okay, and while looking at this here, if you put a into this thing here, it will spit out b, and then if you put this b here into the inverse function, it will spit out a. That's the whole point. Well, this thing here will work for any function. So we are now looking at one specific function, which is e to the power of x. Now let's look at it. Now let's look at it the other way around. At the moment, we are putting the original function into the inverse. So now let's try and look at it in terms of us putting the inverse into the original function. So at the moment, we are putting the original function into the inverse function at the moment. Now let's switch it around. Hang on. So now let's switch it around. We are now going to put the inverse into the original. So now this is our inverse. Put the inverse into the original here. So now put the inverse into the original, you will get this. Okay, and then that will, again, it will spit out the original value that you put into there, which is x. So whenever you see this e and then to the power of a natural log of x, these two will kill off each other here. These two will kill off each other here, leaving you x. Okay, because again, this thing here will work for any function, no matter what. And then now we're just looking at it in this specific case of e to the power of x. If you put the inverse function into the original function, if you put the inverse function into the original function here, it will give you x, which is the case. So whenever you see this thing here, these two will cancel each other out, leaving you the x. Okay, so yeah, okay, so well, I hope you understand it.